This is July 20, 2006. We have two interviewees this morning for the oral history collection at the University of Alabama in Huntsville. We have Kim McCutcheon and David Hanning. One of the objectives of the oral history collection is to have an oral history record that goes with each of the major collections in the archives. And one of the major collections recently completed is one on aircraft engines and the history of aircraft engines. And so this morning it's our objective to record the history of how that came about. But before we get into that, Kim, let's give you a chance to tell us a little bit about your career, how you got into this kind of thing, and how the collection came about.
Okay. I got into this pretty much as a lifelong interest in aircraft and aircraft engines. I started hanging around a local airport when I was 13, and I worked my way through high school and college, washing airplanes and pumping gas into them, and the kinds of things that kids did at airports at that point in time. I studied engineering when I was in college, worked in the field of computer system development, and when I retired at the age of 40, I decided that I wanted to pursue aircraft flight instruction, and I started a business working on aircraft, and that went from 1993 to 2001, I suppose. And along the way, I got interested again in aircraft engines and wrote a book about a very obscure one. And one of the things I found was that it was very hard to locate information about these engines. The information was scattered all over the world and often had been collected by enthusiasts and hidden in their garages because the companies that built them weren't really interested in keeping much of the information around about them. So with that in mind, I talked to some other people that had written books about aircraft engines, and these people were Graham White and Dan Whitney, and they helped with the concept of the Aircraft Engine Historical Society, and using a book from a nonprofit organization about how to start nonprofit organizations, I wrote the articles and bylaws and founded the organization in I guess it was July of 2000. And almost immediately we put up a small website, and people started sending us donations of books and tapes and films and all kinds of things, which David has seen and processed very, very well.
So, how did it come about that the collection of the Aircraft Engineering Historical Society ended up here at UAH? That's a piece of history we should probably report.
I had been a student here at UAH from 1970 on and off through, I suppose, about 1983.
I think you were an officer in the Student Association.
Right. I was involved in the UAH Student Government Association and was president of that organization in, I guess, 1974 through 75. And I always had connections to UAH and knew about the library here and its interest in technical matters.
Well, then that is what brought you here to suggest that the university take the collection, or how did that come about?
All these books and films and things started rolling in, and I had two problems with them. Number one, I didn't have time to organize them or be the librarian over them. And I also didn't want them to sit around in my attic or garage and deteriorate further. So I thought that getting them to the archives would be a good idea, and I got the board of the Historical Society to approve that.
So with that approval, then the university took custody of the collection?
Right.
And when was that? About a year?
I suppose that was more than a year ago now.
Yeah, I've been working on it about a year. So
You've been working on it.
I guess it took me about a year.
We started bringing things here, I suppose, in the fall of 2004.
All right.
And since that time, it's been processed and the catalog of it put online.
Okay. Well, David, you've done the major chore of putting it online and getting it organized here at the university. Of course, you're a volunteer, so maybe for history we should get a word or two about your career and how you got interested in such things.
Well, I didn't start out like him. I'd never really, I guess you can't say I had a love of aircraft, but since my career spans from 1957, approximately, after college, I joined the Magnavox company. And at that time, I was working on vacuum tube computers. And we had a contract with Eastman Kodak. And I worked on what they call a filing sorter, but actually it was a microfilm. This computer happened to be associated with processing microfilm, small bits that we called a stack, and each document on the microfilm was about 12 documents on a 1/2 inch by inch. Then I took a little stint in the Army, a little sideline, rejoined Magnavox, and then this is the first time that I got thrown right into the aircraft systems business. Was the APQ-94 radar. In fact, it was the APQ-83 radar, and then I worked on the 94, which is other advanced version of that. That was really got me started in doing things in aircraft systems. My whole career doesn't span everything involved with aircraft systems, but I was pretty much thrown into that, and from there on, after the radar stint, and of course I kind of ground my teeth on basically radar principles, antenna design, waveguide design. I was more in the RF section of that group than I was with the systems part of it. And then I joined RCA in Cambridge, Ohio, and was thrown, primarily there was working on the Minuteman missile program, and that was totally different. It was a different bunch of people. In fact, I felt like a fish out of water because of the fact that I really wasn't that educated in computer design, and of course that's what we had. The launcher racks were basically old-fashioned transistorized computer, but during that time they kind of figured that this wasn't really my big interest area. They got me with a couple of researchers, and we started to work on communication systems using pseudo-random codes. And I probably built the first 5 megabits, 256 length pseudo-random code that we were using for scrambling of the voice messages and digitizing it, and that group was really fun to work with. Then my career went on to a company that, when I really got into aircraft power systems, was the Hartman Electric Company. And I don't know whether you ever heard of them, but Hartman was formed something like 60 years ago, and now it's 70 years ago, by a fellow named Frank Hartman. And he really started out building radios and then decided to get into building relays and power contactors for aircraft. And this is where I really started to appreciate aircraft technology and being able to design contactors. And so some of the aircraft, I can tell you a lot of interesting stories back in those days, especially with the C-130s, because we built a number of systems of sensors. Primarily what we built was large contactors for power transfer, and then we went into, my job basically as an electronics engineer was to design sensors that would work with the large contactors. I was not really a contactor designer, although I did take a few courses from the chief engineer who taught some courses on relay design, which was kind of interesting. So that was not all the work was aircraft. A lot of it was submarines, some of it was surface ships, but most of the time it was aircraft. We were involved also with some of the NASA projects. One of our engineers designed some of the relays for the LEM mountain module, which was rather interesting. And then from there on...
Little by little you slipped into the aerospace.
Yes, I kind of slipped into it and then sort of stayed in it because years later I joined SCI, and my career was, I think I spent, oh my heavens, over 20 years with SCI. I started out when SCI was a very small company. But we were doing a lot of aircraft systems work at that time, primarily cockpit voice systems, and that was a very big opportunity there to get into fighter aircraft and kind of understand what was going on with the communication system. So, and then I was placed in charge of research and development, and that's where I stayed before I retired, and a nice career there with FCI. But that kind of summarizes. And then how I got here to UAH was I was being bored in retirement, and I called Dr. LaQuire, and I said, do you guys ever use volunteers? And he said, oh yeah. He said, I want you to talk to Ann Coleman. And I talked to Ann, and she was really a sweet gal, and says, yeah, well, I can use you. She said, we don't really have anybody in the technology area. And so my first job there was basically photographs, NASA photographs, and then my real job was the guide to the collection of the Aircraft Historical Engine Society, and we're very proud of this, and I am too, because
tell us a little bit about it. What all's in it?
Well, this one is broken down. When you start on these kind of projects, the first thing you try to do is to set up a series. We use what we call a series, and that defines the various aspects of the collection, and that's the hardest part, because once you commit to that, you have to also think what happens if somebody adds something to the collection. Is that going to throw this whole thing into a problem for the database and trying to get things organized?
Of course, this is a living collection.
This happens to be a living collection, because at any time you could add to this, and I can go back to the database and we can put this information back into it. So we try to make it as flexible as possible. This particular collection, and I don't have all this committed to memory, so I'm going to have to look at the index. But we basically broke this down into 9 categories. In this case, the 9th one was where somebody added some things that we added to the collection, and that was mixed aircraft subjects. And it was mixed aircraft subjects because it is not broken down into separate series. So it's just kind of a little collection by itself, and you kind of have to go in there and look at it to find out. But in this particular case, hopefully we defined as much as we could. A lot of it was just the way the way the thing was organized to start with. So that's hats off to Kim, because it wasn't that difficult to get it organized to the point where we could understand what we had. Now, there's always a case where you can go back and change a few things, and you kind of wish maybe that you did it a little bit differently. And so each collection after that, this is kind of the stepping stone.
The second system.
Yeah, and this kind of became the standard that Ann, and I say Ann and I, have worked on. And we wanted to make it so that anybody else that comes in that wants to volunteer to help us with putting together archival collections, they'll have something to look at and say, this is kind of our standard. And I'm now working on the Dr. Forward collection, and that has been a big help, is to have this first one under our belt.
Very good. Well, Kim, let's go back to you. What do you consider the gems in this collection? Things that are really unusual or important?
There is a lot of technical data in this collection that probably doesn't appear anywhere else. Much of it produced by the Army and Army Air Corps, Air Force later on, that was related to maintenance of aircraft engines and aircraft engine systems. And much of that has been thrown away. It's difficult to find anymore, so it's good that we were able to preserve that. Another thing that's there is a collection of films and film strips that were used as training aids during World War II and shortly thereafter. And that's another thing that I'm glad we were able to preserve.
How large is the collection? Either one of you in?
Well, it's 300 and some documents, once again, committing this to memory. In fact, I had forgotten. It basically, 300 and some and 21 linear library feet, as we call it, of shelf space for the collection.
This is, of course, now available for any scholar or researcher to come and and use and find information. Out of curiosity, what do you do about something like the shuttle? You know, is it an aircraft or is it a rocket, or what do you consider? The shuttle?
Well, he does cover rocket engines. The collection does have.
It does have rocket engines.
It does have some, but not. You know, it's primarily jet. I'm thinking of jet engines, primarily not rocket engines, but it does cover the jet engines.
And our original charter for the Aircraft Engine Historical Society was to cover any means of propulsion that was used for things that fly, whether they fly in space or in the atmosphere of the Earth, or for that matter, of another planet.
Like JTOs would be right down the line, I presume you have.
They would.
Information on those. What other oddities are there, unusual things in the collection? Anything that catches your fancy?
There's a large body of NACA and later, I guess, NASA reports that had been accumulated.
The most interesting ones for me were the way back before the war. We did things so much simpler than there would be a little guidebook in there, and you would read this little book, and practically handwritten, you know, about aircraft safety. I think these were really interesting little books and interesting guides that you find as you go back and look at the old information. Is more interesting to me, the antique part of it, than the modern.
How far back does the collection go?
Well, I think it goes back to the 30s. I mean, once again, you'd have to look at the guide, but it certainly goes back a long way.
Probably late 20s or early 30s. And there may be a few things that are even further back than that. I don't recall.
I thought I should add a paper that I have. It was written by, I think this was a Boeing bulletin that was put out. I'm sure it was Boeing, and it's a 1930s type document. And it's when they first started to put radios on planes. And it was a horrible problem because the static and the engines would generate so much hash that this was a complete article on how you can go about putting the shielded cables on the thing, and it's an interesting document. I probably should just bring this in and log it in because it's an interesting document.
That was a major effort in engine design, was to produce shielded ignition that could accommodate the addition of radios to aircraft, because they were all just unshielded spark plugs up until that point, and they had to figure a way to put metal around the spark plugs, around the ignition cables, around the magnetos, so that it didn't make all this radio noise and make it impossible to communicate.
Well, it's interesting about this collection. One of the things that was so close to me is the fact that I have a patent in jet engine ignition systems, and it was an ill-fated attempt to basically get rid of the Bendix company, replace it with a Hartman electric ignition. And I'll never forget this as long as I live. The invention was really based on what we call controlled capacitor discharge, and it was kind of taken from the radar days of pulse forming networks. And so we used the pulse forming network to put a uniform plasma across the plug. And we would basically use the plug as a TR device. Once we could break it down, then it would allow this power pulse. And our theory was that we thought they could get better starting combustion with the engine. So we approached GE, and GE said, well, we're building this new C5A engine, and yeah, we would be interested in seeing what you're doing. So we got this whole thing together, took it down to Evendale, and the guy tested it on the bench, and it worked okay. And he says, then he got up and he went over to a cupboard. He said, now I'm going to give it a real test. This is the foul plug test. Needless to say, all our little unit did was go pip, 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 pip. Instead of the 3,000, there was, I think we discharged 3 joules of energy across the plug if it was working good. Well, it didn't do anything. It just sat there and looked at us. And the guy put his little plug back, and he said, well, I guess the test is over with. You guys need to go back to the drawing board, because he said, this will not do.
That is indicative of the whole history of aircraft engine development, because the guys that did this early aircraft engine work didn't have the fancy computer models and analytical tools that we use today to design things. So they would do the best they could at a design and try to get it running as soon as possible. And they'd break it, decide what broke and how, go back and redesign those parts, and keep doing that until they had something that was moderately successful.
One of the documents that I noticed come into the archives was a report from the scientists who went into Germany right after World War II and made a catalog of the technology from Germany that might be interesting to the U.S. And one of them was a listing of the German aircraft engines. Did that end up in the collection?
Now you got me. I'm not sure, unless Ann, well, I know, we both discussed that,
Yeah.
but I think it did, but then I'm not sure. And that's a good point. I need to go back and look, because if not, we want to add that.
Yeah,
It seems to me we were trying to find, I think we were going to acquire a copy of that. Is that
Yeah,
what it
we-
was? Or we did make a copy of it.
We made a copy of that
I think
document. We borrowed it on interlibrary loan.
I think it's in here. I'd have to look, but I'm pretty sure that we did add it.
It was a commentary by a group of scientists sent right up with the advancing troops as the U.S. overran Germany at the end of World War II, picking up all the technology they could, and one of the things they did was make a listing with characteristics and so forth of the German aircraft engines. So that's an interesting little piece of history that if it isn't in this collection, it is in the archives.
Well, that's my task now. Go look and see if we put it in here.
There was a lot of work done, both during the war and immediately after the war, with captured engines, where they would bring them to the U.S., take them apart, figure out how they worked, put them back together, run them, try to modify them. All of those things are done, and many of them are reported, and it's fortunate we're starting to find these things, because the Japanese and German engines were, in their own ways, works of art, and they have not been very well documented in terms of the grand scheme of things.
During the last few years, there have been some remarkable flights made with very light aircraft around the world, on one refueling and things like this. Are those engines represented in this collection?
I don't believe so. I think our collection stops about 1950, perhaps to 1960.
Well, where do you see the future of this going then?
I hope
Should
people,
it be brought up to date, or what's going to happen?
I hope people continue to contribute material to it. We have in our society many people that are interested in reciprocating engines, but there is a generation of people coming along who cut their teeth on jet engines and who worked on more modern engine concepts for unmanned aerial vehicles and space propulsion.
So we have an open invitation for people to send more information of that kind then to the
No, we do
archive.
indeed.
I think it would be a real interesting thing, and I see that missing in the collection, is what's the jet engine history? Because I had a boss that I worked for who was he'd worked in the test area at GE, and he told me some really fascinating stories about some utter disasters with these engine testing facilities, where the engine just flies apart. And that would be great to have some other people contribute their history and their knowledge of what went on.
Hopefully some of the people that listen to this online will be motivated to send in material that can augment the collection and make it more comprehensive. Is there anything more either of you would like to add for the record on this activity in this collection?
Well, I can tell you of some interesting disasters on the C-130s that happened to me, but then, I don't know. It's just, they're interesting stories. One of them was that Lockheed was always changing things on that airplane, and they didn't always tell the vendors. And we had went through a total redesign effort. We had 4 frequency sensors that monitored the main generators on each engine. And Lockheed had went through a period of time when they changed the generator specs, and they changed the generators. We were always using MIL 704 as our standard, and those have the envelopes. As you wind the generator up, it goes unregulated for a while. And I was given the task to redesign the sensors because the old ones were not competitive, and but yet they worked. They were good, but they were based on a passive filter and a D'Arsenval type meter, which was turned into a switch, and that's the way it worked. When the frequency reached the right thing, this thing would close. And so I got this big bright idea that I would go redesign this whole thing using operational amplifiers and active filters. Well, I built the thing. The things worked great, and they worked great in temperature. They were smaller. They were not going to cost the company a lot of money. We'd make some money on it, and so we sent our first shipment out, and then I started getting reports back. Failures of the frequency sensors, failures of the frequency sensors. Finally, chief engineer Lockheed says, you need to come down here, and he said, I'm going to set up about 20 of these on a bench, and they said, I want you to look at it and see what's going on. Well, right away, I was looking at an oscilloscope, and I saw what was happening. It was instantaneous. I saw the envelope of the generator come up. It went up almost 100 volts higher than we had designed these things, and the units were all on this big long table, and I'll never forget this. They were going pop, 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 just like firecrackers. They were blowing the regulator circuits out. And I said, okay, I know what the problem is. We can fix it, but I sure wish you guys would have told us to change the generators.
I have a couple of things that I'd like to say. First, I'd like to commend Ann and David for the excellent job they've done in cataloging this information, for making it available online, both as a searchable database and also as a browsable database that you have a hard copy of there. And also, I'd like to put in a plug for the Aircraft Engine Historical Society. We're completing the catalog of a huge body of records at the National Archives, which describes the acquisition of engines, propellers, aircraft, all the things that it takes to make an airplane by the Air Force between 1917 and 1950. Much of that has been cataloged and is online, but it's an ongoing project. And I invite people to visit our website, www.enginehistory.org, and view some of the things that are available at National Archives.
Very good. Well, with that, let's close the interview and thank both of you for coming in. It's been an interesting conversation, and I'm sure the audience will be interested also. Thank you.
Thank you.
Thank you.